So we're going to graph this function. We're going to find its inverse, and we're going to graph that inverse. When we're doing these, we need to make sure we label which line is which or color code it. But I need to know which one is the f of x and which one is our inverse. We're going to work a couple of these, so I'm going to pass out graphs. I don't know that we're going to get through 3 graphs, but that's just kind of how I have the pages set up to print. So I have them in groups of 3 because I'm not going to reprint for individual days. These sets of 3 graphs. What's that? Yeah. All right, so this is the first one we're going to do. We're going to start by graphing this line, then finding its inverse, and then we're going to graph the inverse. You can do it in whatever order you want. If you would rather find the inverse and then graph both lines at the same time, that's totally okay. I do not know what order you fill your page in. But I tend to do graphing the function so that then I can focus on my inverse and all of its things, and then finish it out on the inverse. So I'm going to start by graphing our f of x here. So if I want to graph this thing, where am I going to put my first point? Where do I start? If I wanted to graph this equation. Yeah, this is in slope-intercept form. So this is our y equals mx plus b stuff. So this is a y equals mx plus b. So we're starting at that b, our y-intercept. So we're going to start at 1. How do I move to my next point? Up 1 over 3 with our slope. Remember, it's rise over run. We run to the right because they're all r's. So we're going to go up 1 and right 3. Up 1, right 3. Up 1, right 3. I could also, as long as I flip both of them, do both of them negative because that would still give me a positive 1/3. So I could go down 1 and left 3. Down 1, left 3. The more points you get on your graph, the easier it is to connect them up as a line. You do also have, on our tables, a fancy schmancy tool. Because we are higher order primates, we can utilize tools. Use the ruler to draw your line, or some form of straight edge. Maybe the edge of your phone, edge of your ID, edge of your calculator for like air. Use a tool. So connect them up. Here we go. I'm being a jerk. There we go. I'm going to draw my arrows on either end. And then since I know this is my f of x, this is the only equation we have right now, I'm just going to label it. I'm going to put it right over here. I'm going to put f of x. That is sufficiently labeled. If you want like colored pencils so you can do things in 2 different colors, I have gabillions. If you want colors, let me know. I'm always happy to give you some. I've literally had those colored pencils for like 5 years. So if we were just asked to graph this line, we'd be there. But now we need to find our inverse. So what do we do in here to find our inverse? What's our first step finding an inverse? I need to swap out my f of x to be a y. That should be our first step every time. Whatever our function is, switch our function notation back to our algebraic. Put it back with a y. Do not make it harder for no reason. It doesn't make it better, it just makes it harder. Then we're going to make our inverse. This is where I take my x and I take my y, and we make them change places. So my inverse, when we write that, this is the step that makes the inverse, is our x equals 1/5 third y plus 1. That's technically our inverse. If we could graph that, they didn't ask us to write it in function notation, so we could get away with it, but that's not something we can graph. That's not a thing we know how to do. Ew, gross. But we can solve this back into slope-intercept form and graph that line. So what do I need to do here to get my y by itself on this guy?
Remove the 1.
Remove the 1. So we are going to start by subtracting our 1 from both sides. So we're going to have our x minus 1 equals our 1/3 y. What do we do next to get our y by itself? Yeah. Whenever we have a fraction and we go, ew, I'd really rather not, multiply by our denominator. Multiply by the denominator, because that's going to make this piece and that piece cancel out. But whatever I do to one side, we have to do to the other side. So I need to take this side and multiply it by 3. So I need my 3 times my x and the 3 times the minus 1. You've got to make sure we hit both pieces there. Because what we're going to have for our equation here is we're going to have our 3x and our minus 3 equals our y. So we got our y by itself here. This is our inverse, f minus 1 of x. Our inverse is this guy here, our 3x minus 3. So we found the equation for our inverse. Now we got to graph it. Where am I going to start for graphing that inverse equation? -3. That's our y-intercept. We have a new intercept. How do I move with this one? Up 3 over 1. Good. Up 3 over 1. Up 3 over 1. Or we could go down 3 and left 1. That also works. Again, the more points you put up here, the easier it is to get your line to be straight. If you just do 2 points and they're really close together, it is really tough to line up that ruler properly. So the more points you have, the easier it is to get a decent line. Whenever graphing lines, you need to go edge to edge on the graph. Do not do a little baby line like this. This does not count as a line. That is a decoration at best. No little baby lines like this. Not good. This is at best a decoration. Lines go from edge to edge as far as you can, as big as you can. I mean, you don't need to be sarcastic about it, fill the whole paper, but fill your little graph. But since that's our inverse, I want to label that. So I'm going to find a spot where I have some space right by my line, and I'm just going to put it right here. This is my inverse of f of x. And you can label it just like that by putting my f of x and my f inverse of x. You can do colors. I could have said that this guy is purple and this guy's green. That works for me too. Make it clear. You can do like thick line and light line. That's fine. Just make it clear. If you need colored pencils because you would like to do a color-coded and you want to take a colored pencil home, I have plenty. Take a colored pencil. I have lots. Okay? I have a vast variety of colors, mostly red and brown, but there's a lot of them. Okay, so when we're graphing our 2 lines, make it clear which one's which. Couple of things I want to show us about inverses and why we have you guys graph them on the same graph here is there's some really interesting things that are happening between our function and our inverse. Because what is our y-intercept on our initial function, on our f of x? What was our y-intercept on the purple line? 1. What is our x-intercept on the green line? 1. What was a y became an x. What is our x-intercept on the purple line? -3. What is our y-intercept on the green line? -3. What was an x became a y. Things that are x's become y's. That's true for every single ordered pair on these lines. On purple, we had a point at 3, 2. On the green line, we have a point at 2, 3. So just like in the Bellwork one where we switched our x's and y's. On the green line, we have a point at 3, 6. On the purple line, I have a point at 6, 3. The ordered pairs switch places. So doing the equation does the exact same thing that we did in the list of points. Inverses are so cool. I will nerd out about inverses. I love inverses. Okay, so that's what we're trying to get you to see by looking at these things. If you're looking at your graphs, whenever we are graphing inverses, they will line up if you fold your paper on the diagonal. So if you take your, I'm going to put it up here in a different color real quick. I'm going to do a gray one, not bright red. If you were to fold your graph along that line right there, like diagonally, corner to corner, and hold it up to the light and look through, they line up 100% exactly. Every single time. They line up over the diagonal. Okay, that's part of the design of inverses. It's because it's reflecting over where the x's and y's are swapping. So every time we do one of these, graph our function and our inverse, it's going to look kind of like an x. There's only one time when they would be parallel lines. It should not be getting parallel lines regularly. And in fact, I don't know that we are going to give you that happenstance. Questions on the first one like this that we've done? Okay.